Welcome to some more Edexcel further maths revision. Today we're going to take a look at some further pure 1 revision. And more specifically, we're going to take a look at vectors. So this primarily involves finding the scalar product or the cross product of two vectors. Sometimes we solve these in geometrical problems and being able to use the dot products in problems as well. Okay, so there's a mix of questions here. I picked a few from the old exam board, and then I've picked some from the official Edexcel Further Pure Maths 1 textbook, like you can see here. So let's take a look at some questions, see what we're dealing with. So this is from exercise 1b, question 10. And what we've got here is we've got some position vectors, A, B and C, which are relative to an origin. And the first question asks us to find this cross product here. So we've got to find the cross product of the vector AC crossed with BC. And then using that information, we need to find the exact area of the triangle ABC. Well, first off, before we can actually use the cross product, we need to work out what AC is, the vector AC, and we need to work out what BC is. So this should be very, very basic from A-level maths and your core pure revision. But just in case, remember, if you want to find this vector AC, we do the position vector of C minus the position vector of A. Okay, so C is 3i plus 3j, so that's 3, 3, 0, minus the position vector of A, which is 2, minus 1, minus 1. Okay, if we perform this, so 3 minus 2, that's 1, 3 minus minus 1, so that'll be 4, and then 0 minus minus 1 will be 1. So that's the vector AC. Let's do the same for BC, and like you can see, it'll be very, very similar, because we've already know what C is, so that'll be 3, 3, 0. Minus, this time we do the position vector of B, which is 6i minus 2k, so that's 6, 0, and minus 2, like so. Perform this on your calculator, or just do it by hand. So 3 minus 6 is minus 3, 3 minus 0 is 3, and 0 minus minus 2 will be positive 2 there. Okay. So we've got the vector AC, we've got the vector BC, now we need to cross these vectors. So if you're unaware of how to cross two vectors, you actually know the method to do it. And the reason you know the method to do it is because it's a method that you need for the determinant of a 3 by 3 matrix. So if I'm going to cross these two vectors here, minus 3, 3 and 2. So crossing these two vectors, well, how do we do this? Well, we set it up as a determinant like this. Along the top row, I've got I, J and K. And now the next two rows are my two vectors here. So AC, I'm going to put first 1, 4, 1. And then I'm going to put my BC here. So minus 3, 3 and 2. And all we need to do now is work out this determinant here. So I'm going to expand along the top row. So remember, how do we do this? Well, if I just do an example matrix up here, so I've got 3 elements there, got my other 3 elements, and then a final 3 elements. So the first one will be I lots of, now because it's this row and this column, the 2 by 2 determinant is this one in this bottom right corner. So imagine you just cross them out, so it'd be get rid of that one, get rid of that one. We get left with them 4 there. So same here, I'm going to get left with 4, 1, 3, 2. Remember, your next term will be minus, so it's going to be minus j lots of the next 2 by 2 determinant. Well, it's going to be this row and this column. So I'm going to get this one, this one, this one, and then this one. Okay, so it's going to be 1, 1, minus 3, and 2. And then because we had the previous one being minus, the next one will be positive. So it's going to be plus k lots of, and again, it's this row, but this column this time. So I get left with these 4 elements here. So that's going to be 1, 4, minus 3, and 3. Okay, so as easy as this. All you need to do is work out your individual 2 by 2 determinants. Well, let me just double check if I made a mistake. No, that's fine. So 4 times 2 is 8, minus 3 times 1, so that's 5, so I'm going to get 5i. This is minus j, but let's just work out the 2 by 2 determinant. So 1 times 2 is 2, minus 3 times 1, so that's going to be plus 3. But because this is minus j, this works out as positive 5, but because this is minus j, it's going to be minus 5j. And then my final term here, 3 times 1, that's 3, minus 12, minus 3 times 4 is minus 12. That's going to be plus 15, because it's positive, the full bit is positive, plus 15k. Okay. And there we have it. So that's AC crossed with BC. And then for part B, so that was part A. Part B is nice and easy. We've done all the previous working for it. You've just got to remember the formula. And the formula is, it's half of the modulus of the cross product. So AC crossed with BC. Okay. So, in other words, we're going to work out half of the product, the cross product here, AC crossed with BC, and work out the length of that. So if we do this on our calculator, it's going to be a half times by the square root of 5 squared, because it's 5i, plus minus 5 squared plus 15 squared. Like so. Okay. And because it's the exact area, I want to keep this as a square root. So this is going to be a half. Put all this on your calculator, and this works out as square root of 275. So in other words, that's the square root of 275 over 2, which I can simplify as being root 25 root 11 over 2. And then my final step to simplify this root 25 is just equal to 5. So my final answer, if I just do it over here, is just going to be 5 root 11 over 2. Okay, and that's my exact area of the triangle ABC. Okay, so just the key part of this is that when you're crossing two vectors, set it up using your 3x3 determinant like you would for Corpure when you're doing the 3x3 matrices. Okay, so it's as easy as that. Let's take a look at another exam kind of question. This one is actually taken from the old exam spec. So this was the June 2009 paper. And like you can see here, it's very, very similar. We've got to work out a cross product. Then we have to implement the dot product with that. Then we have to find the area of a triangle and then the volume of the tetrahedron. Okay. Now the nice thing about this question is each part builds upon it. So let's just work out the cross product first. So B cross with C. Well, B is 3i minus j plus k. And C is 2i plus j minus k. So what I'm actually doing here is 3 minus 1, 1, cross with 2, 1, minus 1. Okay. Well, if we cross these, again, setting up our determinant here, it's going to be I, j, k. 3 minus 1 and 1, 2, 1, and minus 1 there. Okay. So now I'm going to expand along the top row again. Now it doesn't actually matter how you expand along here, but I always like to keep it very methodical. I'll always expand along the top row. So I'm going to have I lots of, again, it'll be this bottom right determinant here. So minus 1, 1, 1, and minus 1. Minus j, lots of, so we get rid of this row and then this column. So I get 3, 1, 2, minus 1. 3, 1, 2, minus 1. And then the next one will be plus k. I've actually run out of room. This question is quite a large one. Plus k lots. We get rid of this row, so this row, and then this column, and I get left with these ones here. So 3, minus 1, 2, and 1. Okay. So let's work out each individual 2x2 determinant here. So minus 1 times minus 1, so that's 1. Minus 1 times 1, so this just comes out as 0. Okay, so I times 0, that's just 0. 3 times minus 1 is minus 3. Minus 2 times 1, that'd be minus 5. Because this is minus j times 5, we're just going to get 5j for that part there. Okay. And then my final one here, 3 times 1 is 3. Minus 2 times minus 1, so that's plus 2. So I've got 3 plus 2, which is 5, and because it's positive, that's 5k there. Okay. So that's B cross with C there, 5j plus 5k. Now the next part asks us to work out A dotted with B cross with C. But we've just worked out B cross with C. So all we've actually got to do now is work out A dotted with B cross with C. But A is just 1, 1, 0, okay, because we have no k component, dotted with 0, 5, 5. So this is going to be quite a nice one. 1 times 0, that's 0. 1 times 5 is plus 5, and 0 times 5 will be 0. So A dotted with B crossed with C is just simply 5. So a nice easy question. You can kind of see how the question follows up from the previous one. Same again now with part C. We're kind of the area of the triangle OBC. Now because we've done B crossed with C, we don't even need to do any previous working. We just use our previous working, or should I say. So this is going to be a half of the length B crossed with C here. Okay. So using Pythagoras again, it's going to be a half times square root of 0 squared plus 5 squared plus 5 squared. So 0 squared plus 5 squared plus 5 squared. Well, 5 squared is 25, and we've got two lots of them. So that'll be root 50, so it's a half root 50. So what I've got here is root 50 over 2. That's a 5, root 50 over 2, which we can simplify as root 25 root 2. So this is root 25 root 2 over 2, which we can simplify now simply as 5 root 2 over 2. That would be the exact area there of the triangle OBC. So like you see, these questions, once you've got the hang of them, they're quite nice. They're very similar. The next one then, to finish off with, is just the volume of the tetrahedron. So like you see, it's just one mark, so it should be pretty straightforward. You've just got to remember the formula. Now the formula, so what I'm just going to quickly do is I'm just going to clear my working. So I'll just clear my previous working. The formula, so if I say V, that's going to be equal to 1/6 of the length of A dotted with B cross with C. Okay. Well, when we work this out, so if you got it on your previous bit of working, remember this is just 5. Okay. So what we've actually got here is 1/6 of the length of 5. So if you were to square it and then take the square root, you just end up with the number again. So this is just 1/6 times 5, which is just simply 5/6. Okay. And that gives us the volume of the tetrahedron OABC. So like you can see, a lot of the time they will kind of help you through it. They'll hold your hand through the question by structuring up to it. So quite a nice question there. So let's move on to something a little bit different. Again, going back to the textbook now, exercise 1B question 7. So we're given that the point with coordinates PQ1 lies on the line with this equation here. And then they give us this equation. And we're just asked to find the values of P and Q. Well, what we know is that if this line here, or this coordinate, sorry, lies on the line, then what we can say, so if it lies, if P, Q, and 1 lies on the line, so my writing's very, very scruffy, so it lies on the line, then what we can say is P, Q, 1 cross with 2, 1, 3 should be equal to this, right? This is our R. This is just a position on the line. So this should be equal to 8 minus 7 minus 3. Well, now all we've got to do is just cross these vectors. So remember, so that'll be 3 by 3 determinant. So it's going to be I, J, and K. Don't be put off by the fact that it's letters. So P, Q, 1. The method's the exact same. 2, 1, and 3. Okay. Then once we work this out, we know that this should be equal to 8. The I component should be equal to 8. The J component should be equal to minus 7. And the K component should be equal to minus 3. So it's going to be I lots of my bottom right elements here. So Q, 1, 1, 3. Plus, minus J lots of P1, 2, 3. P1, 2, and 3. So remember, this should be pretty straightforward just from your core pure. And I've got plus K lots of my bottom left elements here. P, Q, 2, and 1. So let's work these out individually now. So it's going to be 3Q minus 1 lots of I. So 3Q minus 1 lots of I. 3P minus 2 lots minus j, so let me just write that out. So minus j lots, I should write it at the start actually, so I lots of this minus j lots of 3p minus 2 plus k lots of p minus 2q. P minus 2q. But like we just said, we know this is our I components, that's I, this is your j, and this is your k. Well, what we're saying is that this 3q minus 1 here should be equal to 8, so 3q minus 1 should be equal to 8. Well, this is dead easy to solve now. This is just a really basic linear equation. Add 1 to both sides, get 3q is equal to 9, divide by 3, and we get q is equal to 3. Okay, so nice and easy. You can do the same with either the j one here or the k. Let's do the k, right? So if I don't mess it up. So we're saying that this p minus 2q should be equal to minus 3 here. So p minus 2q. But remember, we know what q is. Q is 3. So minus 2 times 3, so that's minus 6, should be equal to minus 3. Okay? Add minus 6 to both sides, and you'll get p is equal to 3 as well. Okay? And that's the question done. That's all we had to do. So remember, if you're told that a point with those coordinates lies on the line of this here r dotted with your n, which is equal to d, remember, this r is just a position on the line. Okay? So don't worry too much about it. Just sub your r in, and then you'll get your points there. Okay? So hopefully that's okay. Let's have a look at the next one now. This question here, a little bit trickier. What we've got here now is two skew lines. So we've got L1 and we've got L2. Now part A just asks us to find a vector in the direction of the common perpendicular to L1 and L2. And then part B, a little bit tricky, we have to find the shortest distance between these two lines. So let's have a go at this. So we've got quite a few different things going on. So to find a vector in the direction that's common to two lines, or common perpendicular to two lines, remember, all you've got to do is actually cross the two direction vectors. So all I'm going to actually do now for part A is just cross 4, 3, 2 with minus 4, 6, 1. Okay? If I cross these together, that's what I get. I get a common perpendicular as a vector to L1 and L2. Okay? So, setting this up now as a determine I, j, and k again. So like I see, this is really, really tedious, but this is the key bit, being able to cross two vectors. I'm going to get 4, 3, and 2. Okay, working this out now. I'm going to have I lots, again expanding along the top row, 3, 2, minus 4, and 1, minus j lots of 4, 2, minus 4, and 1, plus k lots of this bottom left here, so 4, 3, minus 4, and 6. Okay, working these out individually now, there's going to be I lots of 3 times, sorry, you've got to take your minus off here, so it's going to be 3 minus 8. So that's going to be 11, right? That's going to give me, hang on, have I made a mistake? Sorry, 3 minus 8. So I seem to have made a mistake, so let me just double check. 4 minus 4, 6, 1, 4, 3, 2, so they're okay. 4, 3, 2, minus 4, 6, 1, that's okay. Have I copied something there wrong? 3, 2, okay, that's what I copied there wrong. This should be a 6, I'm going to say something's not working out right. I can't read numbers, so 3, 2, 6, 1. So 3 times 1 is 3, minus 12, so that's going to give me minus 9 I there. Okay, minus j, so 4 times 1 is 4, minus 8, so that'd be 12, and then you've got minus here, so it's going to be minus 12j. And then finally for the k, 4 times 6, that's 24, minus 12, so that's 36, and because it's positive here, it has to be positive again, 36k. Okay, this bit's a lot easier when you're not doing it under pressure. So you should be okay in your exam. Now what this actually gives me, this is my n, okay, so that's my common perpendicular between L1 and L2. So minus 9i minus 12j plus 36k. Okay. Now part B is a little bit trickier. So what we've got to be aware of here is that the shortest distance between these two lines, remember because the skew as well, we're told that the two skew lines, remember that the shortest distance between skew lines is equal to the length of the perpendicular between these two lines. So what I'm going to have to do first is I'm going to have to subtract the position vectors, dot that with my n, and then divide it by the length of my n. So what I'm going to do here is minus the position vectors, so let's just write this down. So subtract position vectors, so subtract the position vectors, and then going to dot this, so dot the result. So I'm going to dot the result with my n, and then divide this result by the length of n. Okay, so them are the three steps we need to do. So I'm going to subtract my position vectors first. So if we do that up here, so 1 minus 1, 1, minus 3, 7 and 2. So 1 minus 3, that's minus 2, minus 1 minus 7, minus 8, and then finally 1 minus 2, nice and easy, minus 1. Okay, so we've subtracted the position vectors. Now I need to dot this result with n. So let's just write this down. So minus 2, minus 8, minus 1. We're going to dot this with n. So you should have hopefully have written down n. That's minus 9, minus 12, and 36. So that's what we're doing. We're dotting the result with n, and then we need to divide this result by the length of n. So remember, we find the length of n by doing Pythagoras. So this is going to be minus 9 squared plus minus 12 squared plus 36 squared here. Okay, so at this point now, all you've got to do is do all this on your calculator. Okay, so plug all this into your calculator. So if you do the top bit, the numerator will be 78. So I've done all this previously. I'm just saving time during the video. So that's the numerator 78. My square root will be 1,521. Square root there. So that's my denominator. But if you do this on your calculator, the square root of 1,521 actually works out to be 39. So this is 78 over 39, which hopefully jumps out at you as being 2. Okay. So the shortest distance between these two lines is just 2. So there we have it. So there's quite a lot of marks for that last part, but hopefully not too bad. So you just got to remember, if it's two skew lines, subtract the position vectors, dot the result with n, and then divide this result by the length of n, just like we did over here. Okay, so I hope that's nice and easy. Let's move on to the very final question now. Hopefully this video is not going too long. We've just got one more question here. Again, a very standard exam style question. So, just like we did with the first one, we have to find AC crossed with BC. Well, again, let's work out AC first. So AC, that's going to be equal to C, which is 440 minus A, which is 1 minus 2 minus 2. Plug this on your calculator, that's 3, 6 and 2. Now let's work out BC, and then we can cross them. So BC, that's going to be 440 again, minus B, which is 70, and minus 3. Do this on your calculator by hand again, and what you'll get is minus 3, 4 and 3. Okay. Now all I need to do is cross these two vectors, so this will be I, J and K, 3, 6 and 2, and then BC is minus 3, 4, and 3. So again, I'm getting pretty tired of doing these cross products here, but we're nearly there. Let's finish it up. So I lots of 6, 2, 4, and 3. Minus j lots, so remember the next one has to be negative, minus j lots. 3, 2, minus 3, and 3. Plus k lots of the bottom left elements here, so 3, that's kind of gone a bit funny, 3, 6, minus 3, and 4. Okay. Look at your individual 2 by 2 determinants here. So I'm going to get 18 minus 8, so that has to be 10i. 3 times 3 is 9, minus 6, that's 15, because it's minus j, it has to be minus 15j there. And then finally for the k, 3 times 4, that's 12, minus, it's minus 18 here, so that's 30, and because it's positive k, it has to be positive 30k. And there we have it, so that's AC cross with BC there. Okay, that's your result. Part B, nice and easy again, just remember your formula. Just have enough room to do it in here. Remember it's a half AC cross with BC. Okay, so we already know what AC cross with BC is. It's 10i minus 15j plus 30k. So I'm just going to do this on my calculator now. So this is going to be a half of the square root of 10 squared plus minus 15 squared plus 30 squared. Okay, plot this on your calculator and you'll get a half of the square root of 1225, and you can either simplify this expression here or just plug it into your calculator, but if you plug it into your calculator you'll get 17.5 for the area there. So it'll be units squared for the area. So 17.5, so that's part B. And now let's finish with part C. So if I just clear all this just so we've got enough room for part C, so erase all the ink on the slide. Well, what we've got here now is that we're being asked to find an equation of the plane ABC in the form r dot n is equal to P. Well, remember, when we're writing the equation of the plane, we've already got the n. The n was just what we worked out, the AC cross with BC. So I can write this now as 10x minus 15y plus 30z. Okay, because that was our n there. So n was 10i minus 15j plus 30k. So we set up our equation very similar. We just replace it with x, y, and z. But what we need now is this p here. Well, imagine you're going to sub in a point here. So I'm going to think about subbing a in. So if subbing a, well, consider that point. So it's 1 minus 2 minus 2. So if I was to sub that in, that would be 10 lots of x minus 1 minus 15 lots of y plus 2 plus 30 lots of z plus 2. But imagine you was to, so forget about the x, because that'll just give you the 10x, forget about the minus 15y, because you just get the same result here. What I am interested in is what I'd get when I multiply out the two numbers. So 10 times minus 1, minus 10, minus 15 times 2, minus 30, and then 30 times 2, that will give me plus 60. So what do I get when I simplify this? Minus 10 minus 30 is minus 40, plus 60, we get 20, right? But remember, I don't want it on this side of the equation, okay? We don't want it on this side of the equation, we want it over here. So I'm going to subtract it off this side. So this is going to be equal to minus 20. So what I actually have here now is r dotted with my n. So r dotted with n, but we can actually divide here. We can divide through here. So this would be r dotted with 10i. So 10i minus 15j plus 30k will be equal to minus 20. Now at this point, you can give your answer like that. That is an equation of the plane in the form r dot n, because remember this is your n, and that's your p there. But you can simplify this if you want, it doesn't matter. If I simplify it though, I can divide through by 5. So I can divide 10i by 5, 15j by 5, 30 by 5, and then divide the minus 20. So what I will actually get is 2i minus 3j plus 6k, can't do maths, 6k, and that's going to be equal to minus 4. Okay, and there we have it. So that felt like quite a long video. I hope it's helped though. So just a bit more revision for you, further pure one. Any questions, please leave them down below, guys. I'll try my best to help out in whatever way possible.